Okay, so there are a couple of questions I hear. So you guys were asking about your exam. Is that true? Good. So Wednesday, your practice exam will open up tomorrow. Tomorrow night, practice exam opens up. Your practice exam will be open up until Monday, okay? Your exam will open up on Friday. So you have from Friday till Monday night, get it done. It's done online. You guys are gonna have to show your student ID. You guys all have student IDs still, right? You can use your Avenel ID or you can use your West Hills ID. I don't know which one you have. You may have both, right? Okay. So you need to show your ID when you guys take the exam. It's going to be proctored by Proctorial. You guys heard of Proctorial before? Okay. What was that? What is the meaning of Proctorial? Proctorial is a proctoring system. So what it does, it's going to be you recording, you taking the exam. So it's going to be recording your screen. It's going to be recording you. It's going to be listening to sounds. So if somebody comes in and say, hey, you know, the answer is 25, right? So it'll pick up that, right? What was that? Exactly. Yeah. Yeah. Yes. No. Yes, you have your packets. Your packets. Yes, you're showing that it's the packet that you're going to be using. And you can also have scratch paper, right? And your calculator. It's based upon all the chapters I handed out, right? So it'll be actually it's chapters 2, chapters 8, chapters 5, and chapters 11. So that's what it's going to cover. Yes. If you don't have a student ID, do you have a driver's license? You have a passport? Okay, so if you have a passport, you can use your passport. Yeah, you can, as long as it looks like you. If it don't look like you, if it looks like your brother, then, you know, you can't use that one. Any other questions? It can range from anywhere from 45 to 60. I haven't decided how long I'm going to make it yet. Yes. That packet. Yes, you can use the packet. No, you could just use the where the periodic table is. Everything that's in that packet. Yes. Yep. Any other questions? Yes, it is timed. Any other questions? Your mask. So it also depends on how many questions I give you. I kind of weigh it based upon the number of questions I get. So it could be anywhere from an hour to 2 hours. It's not all multiple guess. No, some of it is short answer. Can you repeat that, please? Yeah, yeah, you're going to be recorded, and it's also going to be like listening to the audio, right? And so it'll recognize when somebody comes in the room. Yeah, go ahead. Yeah, and it's going to record, and then anytime that you guys do something crazy, let's say you get up and take off your clothes, it'll give a blip that said, you know, and so then it gives me a signal, and it gives you guys like scores. Person who cheated the most, the person who cheated the least, or who it believes to cheat the most or cheat the least. And so then I go through and I take a look at it. Okay. And so then it shows you all of the areas that you guys messed up on. It picks those up. Yep. If you guys, you know, go out the tab, if you search something else, it should block you and it will kick you out too. Yes. It isn't set up so that you can't leave at all, but let's say you leave and you come back 30 minutes later and then you answer 50 questions, right? Just like that, then it lets me know, right? It also picks up like cell phone signals, right? So it's able to sit there and recognize that as well too. So if you guys are texting during the exam, it picks that up and it gives me blips on that. Yeah. I can't hear what he's saying. Let me hear what he says. Yes, you can go to that. Okay. There's another question. What if you faint? Well, it'll recognize that you fainted, right? And there's nothing I can do about, it's not going to call 911 or anything like that. It'll put a blip on there and says, should you ever show back up to the exam? What was that? So, okay, so when you guys, I recommend that when you listen, hey, I don't like repeating myself a lot. Okay, so she asked, what if there are other people in the room? I recommend that you pick a time where there aren't a lot of people up or a lot of people running around in the room, because it picks up all of that information. If it has the ability to kick you out of the exam, right? If it kicks you out of the exam, you want to contact me immediately, right? To let me know and let me know the circumstances, because usually it kicks you out for a reason. Like for instance, we had one student who closed the tab, right? And she kept closing the tab in the middle of the exam. And she's like, well, I don't know what it did. I'm like, well, you kept closing the tab. So then that meant that you were doing something else and you tried to hide what you were doing. And so it picked that up and so it kicked her out of the exam and locked her out. And so it would stop at that point, and that would be the grade that you would get. Okay. Now, if you contact me and if it's, my little brother was jumping on my lap and all that stuff, and it somehow just, okay, let me know. And then what will happen is that you have to retake the exam. And the exam that you get, that exam will be different than the exam that you initially started out. It usually recognizes, like, there's one case where I had a student, she had a cat, she had a bird, and they were just all over the place, right? And so things like that, since it's so small, it just lets it go. It marks it so I can take a look at it, but it lets it go. Now, if you could teach your hamster to sit there and do chemistry for you, then you can cheat all you want to, because man, that's something, right? It just says on that, it'll just say crazy, a little bit, and then, so usually things like that, if you're by yourself, that's fine. It usually doesn't recognize it. Now, if you do this and you look at something, it's going to recognize that somebody else is in there. Well, if you were talking to it at the same time, if you do this and acknowledge it, it's going to recognize that, right? Again, it'll probably say crazy on it, and then, okay. Any other questions regarding proctorial? Okay, now here is the secret. On Thursday, today's Tuesday, right? On Thursday, during your lab, we'll go through, get proctorial set up on your laptop. We'll get it set up then, so you guys don't have issues getting it set up. Because I guarantee you, when I was teaching online, I spent days, like 4 or 5 days, getting everybody able to use proctorial so it doesn't kick them out, or so that they can actually get started with the exam. So then that way you don't have to wait till the last minute to sit there and get it done. You'll have it done. So make sure you guys bring your laptops on Thursday, because that's going to be the first thing that we do. Okay. And that's also in DC, you guys need to make sure you bring your laptops tomorrow, so you guys will be able to sit there and do it. Now, if you are, let's see, on Monday, you guys get here what time? Here in Avenel. This class. You guys get here at 11:20, okay? And then you guys go to lunch at what time? You guys go, so you guys come here after lunch. Okay, so after chatting. So what we can do, if you feel more comfortable, we can set it up so that Jessica can proctor you, right? If Jessica's okay with that during that time period. Are you okay with that, Jessica? Yeah. If you're not, let me know, Okay. And so under those circumstances, we'll make some adjustments. I'll have to make some adjustments on those people who are going to do that. But that means that for all of the other people, right, who decided they're going to take the test early, then what we'll do is we'll set it up so you guys either don't have to come to that part, or, something like that. No. So what we're going to do is I'm giving them the option of, if they're worried about proctorial, because a lot of them get really worked up. In that case, you'll be proctoring their exam. So, yes. Yeah, you're going to be able to do it as many times as you want to. You're going to get different ones, yeah, at different points, yes. Don't worry about it. You won't bank my test bank. You can do it 100 times and you still won't bank my test bank. What was that? No, that one won't be on proctorial. It's just whatever, just do it. And I recommend, and this is what I recommend. Okay, so you guys understand, you guys can study together. You guys can work on things together, right? I give you guys one exam that you guys are going to be, it's like a group exam. You guys can work on it together if you want to, and then get together and you work on the problems, right? I love those exams because usually I have one problem that is so hard that, if there's one person, there's always that one smart person, they get everything right. And then there's that one problem that they get their butt kicked on. And then they have everybody going down that same aisle. So that I know exactly what went on in those situations, right? So that lets me know well in advance. I think was it your class that happened? Yeah. Yeah, I think it was your class. Yeah. So, and usually it happens in almost all my classes. You always have that one, and they try to tell everybody else how to do it, and nobody, questions it in any way. And so then they all get the problem wrong. And so usually those are worth like 25 points. So that's a quarter wrong. So, the highest grade that I got during that exam was a C because of that, right? And so I always like to give at least one exam like that. It's a take-home exam, work with anybody you want to work with, do what you need to do, right? Except the only thing you can't, although their exam, I actually had it open, they could give it to anybody they wanted to, right? That question, it went back to my old instructor. My old instructor contacted me and said, a couple of your students had sent questions about this question to us, right? And so I got well in advance of how people were doing the test, right? So.
Okay, the lab report that we was discussing today, now I've seen on Canvas that is due tonight, but I know you said tomorrow. So are you gonna go back in there and fix it, or?
I'm gonna go back in there and fix it. It's gonna be due tomorrow night. Yes, today's Tuesday, right?
Yeah, today's Tuesday.
Okay, I'm just making sure. Yes, it's gonna be due tomorrow night.
Okay.
The problem was that I messed up on the date. I thought today was the 15th. I thought today was the 14th and tomorrow's the 15th. So I'll fix that. Your lab report, your very first lab report is due. The mental lab report is due tomorrow night at 11:59 p.m. So you want to make sure you have it uploaded by that point. Okay, so see how much you guys remember from yesterday. So we talked about protons. What is the charge on protons? Protons are positive. Okay. Neutrons? Neutrons are negative. You want to put money on that? Neutrons neutral. Okay, meaning they have no charge. And electrons negative. Okay. Okay, so how can I find the number of protons? Okay. Okay, wait, who said that? Good job. Okay, so we use the atomic number to determine the number of protons. Yes. Okay, and then Alicio told us, how can I determine the number of electrons? By the number of protons. They're equal for, in what case? Are they always going to be equal, or is there? Okay, so we're going to talk about that today. We're going to talk about it a little bit today. Okay, so I want to give you guys a little test run to see what you guys know. We'll see how much you guys remember from everything that we talked about. Oh, wait, how do I determine the number of neutrons? Mass number minus the number of protons. Okay, that is correct. So let's see what you guys know. Okay, so we're stuck on mercury, right? Okay, so you said mercury had how many Protons again, you said 80, right? And how many neutrons? 121. So how did you calculate 121? Okay, I minus 200 by 80. That's right. So we have to round it, right? Let's see. So if we have 201, that's going to be my mass number. Minus 80. Get 121. Okay, so there's 121 neutrons. Simple, not too hard. Okay. Let's see, what about silicon, Si? So we have 14 protons. And we have 20, you said 28.1. Okay, so 28.1. Is that my mass number, or is 28 my mass number? So 28 would be my mass number. Because what is the rule about mass numbers? Are they going to have decimals? No, they're going to be whole numbers. Okay, so it's 28. Okay, so if I have, you said I have 14 protons, how many neutrons do I have? So how many electrons will I have? 14. And why will I have 14 electrons? Does anybody know why we have 14 electrons? Because there's 14 protons, right? And why is that pertinent? Yes. The atomic number. Atomic number. Atomic number is always the number of protons, right? Okay, so let me tell you something, okay? So the number of electrons can change. The number of neutrons can change. But the number of protons define that element, okay? Did you guys hear that? I'll repeat it one more time because you're probably going to run into that on the exam. So the number of electrons can change. The number of neutrons can change. But the number of protons are always going to be the same because they define that element. So if I'm talking about carbon, how many protons does carbon have? Okay, so we know that carbon always has 6 protons, right? So will somebody ever say carbon has 7 protons? Okay, now that we've kind of talked about that, you guys kind of got that in your head. Now I'm going to really throw you for a loop because I told you that electrons can change and I told you that neutrons can change, right? Okay, so we have what we call an isotope. Let me see. I'll spell that for you. Isotope. Okay, isotope basically means that you have an element that weighs different than what you see on the periodic table. Okay, so let me give you an example. Carbon. So normally carbon has a mass number of 12, right? But carbon also has an isotope, carbon 14. The way that we write an isotope, we write it like this. We write it as 14 small superscript in front of the C. So that lets me know that I changed the weight of carbon. So that weight is no longer 12, it's 14. What was that? What did we say about the number of protons? Okay. Okay, is it the number of electrons? Okay, are you listening to what I'm saying now? Listen to the words that are coming out my mouth. Okay, pay attention. Okay, I said you could either be changing electrons or you could be changing neutrons, right? I said that 14 tells me it weighs different. Now it weighs 14 instead of weighing 12. So what do you think is changing? The number of neutrons, okay? So an isotope. Yes, so this here, this C14, that's an isotope. Let me erase all this other stuff. So it'll also be written as, like I just said, C14, or they'll say carbon 14. So you'll see it written like this as well. I'm having a lot of trouble with it. Okay. So C14, or you'll see it written as carbon 14. And then sometimes you'll see it written as this. It'll say 14, 6, right? So this here, it's going to represent the number of protons, or the atomic number. So these are 4 different ways of writing isotope. Okay, so we just said it. Alicio, I'm going to mess it up. No, I'll get it right. I'll get it right. Tell me again, one more time. Adicel just said that carbon is changing. Carbon 14 is changing by the number of neutrons, right? So we know that neutrons affect the weight, protons affect the weight, but electrons don't really affect the weight, okay? Because they're so small compared to the other. They weigh so little compared to the other. Remember we talked about that yesterday? I know, it was like years ago, right? Okay, so now that we've kind of understood that, right? So now you've been introduced to isotopes. So you have what we call an element, and you have the isotope that's associated with it. Now, really what an element is, what's on the periodic table, is just a combination of all of the different isotopes. So you're going to ask me, what do I mean by that, right? That could be the next thing that comes out of your mouth. Okay, so in nature, naturally, you have some isotopes that naturally occur. Okay, but you have the ones that are going to be the most abundant. So in this case, we know that carbon 12 is most abundant because the weight that's on the periodic table is close to 12. So carbon 12 is the most abundant, and you see that it's like, if you look at the number that carbon has, let's see, let me click on carbon. Okay, so I clicked on carbon, right? You see it's 12.011, right? That 12.011 tells me that those other isotopes that other than 12 exist. That's the reason why we have 0.011. They're very, very little, right? But they exist, okay? So we know that we have a carbon 14 and there's a carbon 13. Both of those exist, right? But they're so little compared to the carbon 12 because it's so close to 12. Now, if we take a look here, let's say, let's do oxygen. We have oxygen. Oxygen is 16.9999, right? So in other words, it's really, really close to 16. So then there's probably a carbon 14, an oxygen 14, or an oxygen 15, to allow it to get to that point. And so are you guys kind of seeing what I'm saying? Or is it kind of okay, that's all right. We'll break it down here. So let me write it down in numbers, because I understand numbers. I'm a number person, right? There's a lot of writing. Let me get a whiteboard. I'll clear it up for you. I'll clear up the spot. Okay, do you guys see my oxygen? Okay, so we have a couple of different isotopes of oxygen. We have oxygen 15. We have oxygen 16. Yep. So if you look on the periodic table, we're saying that the majority of them are so close to 16. we're going to say like 90% of them, 99.9% of them are going to be 16. Yes. So yeah, so if we picked out 100, let's say 1,000. Let's just say 1,000. Let's say we picked out 1,000 different oxygen atoms. That's right. Yes, exactly. Exactly. So if we picked out 1,000 of them, then 999 will be the oxygen 60. And then only 0.1 would be the 15. Okay. You guys understand that? And so if you take the average of all of them, you're going to end up with that 15.99. Okay. So let me tell you what isotopes are, right? So we talked about isotopes. All we know about isotopes is that they weigh different than what we see on the periodic table. Well, isotopes, if you take a look at it, both of these are, quote, considered isotopes, right? One is more stable than the other. The one that's most abundant is the one that's stable, right? It's around a lot longer. So that's the reason why the other one, 15, is so low, is because it's not stable. It's going to break down. Now, when we talk about stability, we've been talking about stability a little bit in this class. What was that? It's more of a nuclear reaction, okay? Not necessarily. It can, depending on the isotope that we're talking about, like uranium. You've heard of uranium. You use uranium to make bombs, right? The atomic bomb. Yeah, yeah. But in this case, oxygen is not, it's unstable, but it's not as explosive as other things, okay? Now, the thing is that about these isotopes, they're unstable. Because they're unstable, they give off a radioactive signal, right? The ones that are stable, the reason why we recognize that they're different, because we see the one that are most abundant. We see this guy, but we see this guy in nature. And it's like, okay, this is what we're normally exposed to. So we don't look at it as being different. Where this guy is different. It's not around as much, it's rare. It's kind of like, have you guys had like a toy that somebody else never ever had? Like, not anymore, huh? There's not like a unique toy. And you're like, man, this is the coolest toy ever. Or yes, a rare Pokemon card. Yeah, exactly. So it's kind of like that, right? So it's kind of like that rarity, right? And so the thing is that it's not going to be around that often. It's very, very rare, right? And because it's very, very rare, it usually has characteristics that are associated with it. And some of those characteristics are radioactivity, right? And so we'll often use isotopes to sit there and determine, certain things that are happening because they're rare and we can recognize them. They give off a signal that we can easily recognize, okay? Are you guys kind of understanding a little bit more? You have that look. It's like, I don't know, Don't worry about it. We'll get into a little bit more, okay? Okay, so on a piece of paper, write this down. Okay, you guys at home, you can actually, if you hit annotate, you hit save, you can copy this. Okay, everybody got this, right? So you guys ready to do this? Excellent. So what I'd like you guys to do, I'm going to put you guys in groups, right? I'm going to put you guys in a break room. Everybody got this? Got a copy of it? Okay, you guys got 5 minutes to sit there and write this down, write down your answers. Okay, let me put you guys in break rooms and then we'll get started. Okay, so it's important that you guys listen, okay? So we're going to start off with the very first part. It's the elemental symbol. What is the elemental symbol for barium? Ba, okay? And those at home, you guys can participate as well. Okay, what is the atomic number for Ba?
56.
Okay. How many protons? I know it's not up here. How many electrons. How many electrons? I know it's not
This
up
one
there.
I'm confused at.
Okay, so if we're talking about an element, right? An element is always going to have the same number of protons as it has electrons. Did I say electrons? Did I say electrons? Make sure. Same number of protons as electrons. Okay, so I know it's not written up here. I'm going to say, I was trying to make room for it, but I don't have room on my sides there. So electrons is going to be the same. Okay, so what is the mass number? Is it 137 or is it 138? Okay. Okay, so barium, if I look at barium, barium is 137. Okay, wait, hold on. So here's the secret here, right? Wait. Hold on. Remember, I just told you that we have what we call isotopes, right? Didn't I just say that? Okay, so if we have an isotope, this tells us the new weight of that particular isotope, right? So this one is going to be 138. So if we're talking about what's on a periodic table, if we're talking about an element, it'll be 137. But since we're talking about this isotope, because they let us know that this isotope is 138, it's telling us it has a new mass. You guys see that? Okay, so the mass number for this guy would be 138. Nope. How do we calculate our number of neutrons? Okay, our mass number is 138. We're going to subtract the number of protons. Oops, did I say that's not 8? That should be 6, right? Oops, sorry. There we go. Okay, so 56 minus 138. Okay, so when we want to calculate the number of neutrons, it's going to be the mass number, right? Here they're using A, mass number minus the number of protons, which is also the number, the atomic number, yes. No, the top number equals the new mass, right? So the top number always equals the new mass. So if we write the name of the isotope, so they want it in this format, how will we write it in this format? So we call it barium 138. Yep, you put the mass number at the end. 138. That's 138. There you go. Okay. Are you guys with me so far?
No.
Oh, no?
No, I'm like really confused. I'm trying to figure out where you getting these values from. I see the 137.33, but are you rounding? I'm not exactly like, I can't
No,
follow.
Okay, that's a good question. So Arya, so this here, this symbol here, the nuclear symbol, this told us here. Now you guys listen, because some of you guys are gonna have the same question in 2 minutes. If you have it in 2 minutes, I'm gonna be nasty because you're not listening. Okay, so the question was, she's like, where are you getting the 138 from, right? So the 138 is being given to us. They're letting us know that we have an isotope. We have a new isotope. It's not what we see on the periodic table. We know on the periodic table, it's 137, right? So did you guys hear that? Okay, so we know on the periodic table is 137. They're letting us know that it's now 138, okay? It's not 137, it's 138. So that means that the one that we're looking at is an isotope of barium, okay? and it weighs 138. So that's going to be its new mass number. So we're going to be using that number. Okay? Yes. That is correct. Yes. So if they didn't give us the nuclear symbol telling us that it was 138, then we would assume that it was 137. Okay? Unless they gave us the number of neutrons, right? Okay, because it's like a puzzle, right? They're giving you bits and pieces of the puzzle, and you've got to put together the puzzle. Okay, so let's look at this next one, right? Are you going to do the next one for me? Okay, okay. Okay, so we have an O for the symbol. That's right. Okay. That's right. It's a puzzle. It's just a puzzle. We're putting together the puzzle. Okay. You don't understand? Okay. So wait, hold on. Quiet down again. Again, you want to pay attention. So we got 18. So we know, how do we calculate the mass? What makes the mass the mass? What gives us our mass number? So we know it's the number that's usually under the symbol, right? But if they're giving us, because we know that the mass number is just the combination of the protons and the neutrons added together, right? Protons, and so they're telling us, they're saying, now this guy weighs different than it normally does, right? Because we know that oxygen normally weighs about 16, right? So, but this one says, no, we have more neutrons. So those neutrons are going to weigh more. Those 2 extra neutrons are going to weigh more than we normally have. Okay, so in that case, we have protons plus neutrons are going to equal our mass number. Are you guys with me? All right, are you there? Do you get it now, or does that help?
Oh yes, I got it.
not-
I was over here
Okay.
figuring it out, and I'm like, okay, now I see what you did. Okay.
Okay. So again, you're given in a table like this, you're given pieces. Now, this is the way science kind of works. It always works in bits and pieces. It's not like, oh, I already got the answer. That's not the way it is. Always bits and pieces. That's an 8. Yeah, that's an 8. Sorry, my handwriting sucks. Yeah. Okay. So what about the next one? What is going to be the element that we're looking at? It's lead. Okay.
Yep.
Pb. Okay. Okay, 82. And you said 124. So the top number, you're talking about the symbol, right? So for the nuclear symbol, the top number is going to be the mass number. The bottom number is going to be the atomic number, or the number of protons, which is the same, right? Okay, questions? Okay, what about this last one? Zn, okay. Zn. Okay, 30. Okay, I hear 33, 36. What is it? Is it 36? So why is it 36? So they're telling us here that the new mass is going to be 66. So then that means, that's right. You got to minus it by 30. That is correct. Oh yeah, on the exam, you definitely will have questions like this on the exam. Okay, questions? Okay, can I move forward? Kalinga, Kalinga, Fireball?
Yeah, we're good, Dr. Hunter.
Okay. So let me give you guys the pretty writing so you guys can see it clear. Okay. Okay, so now let's go back to Dalton's laws, right? Because this is what we're all kind of building up to. Dalton had said that things were indivisible, right? You couldn't break them down. Well, we know that isn't true because we can get protons, neutrons, and electrons. And we could either have more neutrons than before, so we could be adding neutrons to it, right? And we can also affect the electrons. We'll be talking about that here in a second, okay? So the other thing that he says, all atoms of an element are identical. Well, I just told you guys that there are isotopes, right? Every element has an isotope that's associated with it. We have the one that's most abundant, but we also have others, right, that exist in nature. So that means that they're not identical, right? They have the same number of protons, but they have different masses because they have different number of neutrons, okay? So the difference in neutrons is what caused them to weigh different. Did you guys get that? I'll repeat it one more time because that will definitely be on the test. The difference in isotopes are due to the number of neutrons, okay? Because we know that the number of protons are always going to be the same. The difference between isotopes are due to the number of neutrons, right? So the masses are going to be different because of the number of neutrons. Okay, so that brings us, you guys have been talking about atomic mass, the mass of an atom, right? So the mass of an atom was defined by carbon 12, the carbon 12 isotope, the one that is most abundant. Okay, that kind of set up everything on the periodic table, where everything is located, how it weighs, and everything like that. So it's based, our system is based on carbon, right? Which makes sense because carbon is the root of life. What is your body mostly made up of? Well, you're right, it has a lot of water. Most of it is water, but what kind of keeps it all together, that makes you human, that makes life, is carbon, right? So why does carbon make your life carbon? Does anybody know? That's right. Okay, so let me show you one little video, and then I think we're gonna stop and everybody's gonna get a potty break, and we'll let the other class go and we'll pick this back up tomorrow. But let me show you a quick video first. Okay, so one of the reasons why carbon is so important to us, it attracts 4. It's able to hold 4 bonds. So I always like to look at it like this. I'm going to say something and you guys are going to giggle and all that stuff, but carbon is a little bit of a whore, right? It can have 4 people that it can relate to, right? It can hook up 4 ways, okay? It's always going to be in the center. When it can be in the center, it's kind of the center of life, right? So if you think about it, the reason why it's so important is because it can connect to so many different things at a given point. What was that? Oh, we actually showed it at the very beginning. You guys remember the model where it's right there in the center and it had the 4 attachments, right? Just like the guy having the 4 people coming to attach to it, right? So the key is that the reason why we use carbon is because it's that nice center molecule. It has that perfect structure that allows it to sit there and do things. And if you look where carbon is at, it's 4 away. If you look on your periodic table, it's 4 away from the noble gases, either way you go. So 1, 2, 3, 4 from a noble gas, and 1, 2, 3, 4 from the other noble gas. It's like right there in the middle. And we're going to be talking about that on tomorrow, on Wednesday.